Before I provide an alternate form of this Laplace transform of a delayed function multiplied by a delayed step function, which is equal to e to the minus sa times f of s, let me motivate it with this example here, where we have a function f of t given as t squared multiplied by this delayed step of 2. Well, we need to put this t squared, which is our f of t, into f of t minus a. After trial and error, it can be shown that our form would be t squared is equal to t minus 2 squared plus 4t minus 2 plus 4. Okay, so now this t squared has this form of this function, and we can show you that by expanding this out. T squared minus 4t plus 4 for this expansion here, distributing the 4 in this term, 4t minus 8 plus 4. We see this minus 4t cancels out with this 4t, and these pair of 4's cancels out this with this minus 8, and that's left with t squared. Now finding the Laplace transform of t minus 2 squared plus 4t minus 2 plus 4 multiplied by this delayed step of t minus 2, we can evaluate the following term by term. So this would be, for t minus 2 squared, we have a delay of 2, so this would just be, so term by term, Laplace transform of t minus 2 squared times u t minus 2 plus 4t minus 2 u of t minus 2 plus 4u of t minus 2, in which I get the Laplace transform for this, and then the Laplace transform of this, and that would equal to each of those terms here. So this is like a t squared, so this is like over 2 over t s raised to the q power multiplied by e to the minus 2s. And this one would be 4 over s squared multiplied by e to the minus 2s plus 4 over s e to the minus 2s. And that would be our Laplace transform for this case. But you could see that trying to come up with this form so that it equals to that f of t has a form of t minus a is a bit difficult and not obvious. So we need to come up with an alternative form for the function defined earlier when we have the Laplace transform of with delayed functions. So that's what I'll do next. Now we're going to try to find an alternative form of the following Laplace transform for delayed functions. So here, let's say we have the Laplace transform of g of t multiplied by a delayed step, and we want to put g of t in the proper form. So we're going to apply the definition of the Laplace transform shown here, but this time we're going to integrate from a to infinity, since the one going from 0 to a is 0, since g of t doesn't turn on until the step function at where the step function is delayed at a. So we'll do a change of variables here, where u is equal to t minus a, which implies that t is equal to u plus a, and that du is equal to dt. So we'll replace these variables, dt with du, replace gt with u plus a, and we'll replace e to the minus st with e to the minus s u plus a. We're going to integrate this from a, but since we're doing a change of variables, t is an a, so u, when you substitute a minus a, the lower limit, that's equal to 0. So we're going to integrate from 0 to infinity. So that's our change of variable function. Now it turns out that this function is actually equal to e to the minus sa, where we factored out the exponential. We have 0 to infinity, e to the minus su g of u plus a du. But this turns out just to be, this part right here is just a Laplace transform of g t plus a, and multiplied by e to the minus sa. Alright, so that's our alternative form for this Laplace transform. So these are equivalent in that respect. Now we'll do a couple examples. So let's apply this alternative form of finding the Laplace transform with this example, where we have the Laplace transform of cosine of t times a delayed step function t minus pi. So here we note that g of t in this example is cosine of t, and that a in this case, looking at the step, is equal to pi, and therefore g of t plus pi is equal to cosine of t plus pi, which turns out to be equal to minus cosine of t. Alright? So in this case, we apply this formula. We already found g of t minus a, so it's really the Laplace transform of minus cosine of t multiplied by e to the minus sa, but a in this case is equal to pi. And then we know that taking out the negative sign, that's just negative e to the minus pi s, and the cosine is just s over s squared plus 1 squared, or simply 1. So that's our Laplace transform for this example using the alternative form.